Hello everyone. In this session, we are going to learn how you can containerize .NET applications and run them on Amazon Elastic Container Services. My name is Srivan Tattanayaka and I'm a partner solution architect at Amazon Web Services. So what's the agenda for today? We are going to containerize an EXE application, an ASP.NET application using Visual Studio. Doing containerization using Visual Studio is super easy. We are going to containerize an EXE application manually to understand the fundamental of containerization, and if you have an application without source code, you will learn how you can easily do that. Once we learn the basics of containerization, we will go and explore Amazon Elastic Container Service and Amazon Elastic Container Registry. We are going to spend only a very quick time learning that, and we will then directly jump into how you can run a .NET application on Amazon ECS. We will then learn how you can create a CI/CD pipeline to continuously deploy containers to ECS. In this case, we are going to explore ASP.NET Web Application deployment. So let's get started. Let's first containerize an EXE application and an ASP.NET Web App site using Visual Studio. So I have started Visual Studio, so I'm going to create a new project, a console application. You can give it a name that you like. What I'm going to do here is to paste some command. So all what I'm doing here is creating multiple threads using task parallel library, and then spark multiple threads and then printing them into screen. Some numbers I'm printing into screen, right? Not very complex to simulate a batch application. So when you run this, it uses all the CPU available and it prints some numbers. So you can find that multiple threads printing some numbers into the screen. Very simple application. To make it Docker enable, I go to Visual Studio, click add, and then click Docker support. So when I add Docker support, it will add a file called Docker file. So if you go into Docker file, you can find that the base image that it's going to based out of, and what application that it's going to run when this container runs. So in this case, C app my batch application.exe. So now I have this Docker enabled. So when I click Docker, what will happen is the Visual Studio will grab an image, Docker image if it does not exist from internet. And if it already exists, it will start building it. So here you can find that it's downloading the image because it didn't have this image locally. And it's going to copy these files, the build artifact, in this case exe, and then deploy it. So you can find that the debug points works as before, right? So the debugging of Docker containers is pretty much similar when you do it on Visual Studio as opposed to when you create a simple EXE application. So if you type docker ps, you can find that behind the scene Visual Studio has started the container. And the experience is pretty much similar if you containerize an web application. So here I have a ASP.NET web application. I click add and then go for Docker support. So here the base image is going to be ASP.NET based image, and it's going to run IIS behind the scene. Right? So you can find that behind the scene it's now downloading that image because I did not have that. And once it download it, what we'll do, it will start this container and it will run IIS with the website. So it's starting the website. The only difference you will find here is that it's, instead of running on local machine, it's running on a special network, which is a NAT network in the Docker. So you will have access to your website. So this website is running inside a container. The beauty here is that if you have some JavaScript that you want to debug, you can easily go here and then make some changes to that. For example, if I make changes to this HTML page, you can find that I can easily view that without restarting IIS or restarting the container. So I just save this HTML page, and if I refresh this, you can find that the changes I have made are reflected. My debug point also get hit. You can find that the changes are being reflected. You may be wondering what happened behind the scene when we make some changes to the website page and refresh the website that is running inside the container. You saw that we didn't restart IIS, we didn't restart the debugging process of Visual Studio, but the changes we made to the page immediately after the change appeared once we refreshed the website. So what happened behind the scene? So you were running your Visual Studio, and when you run the Docker container, it spin up a new container with IIS running inside, and it then mounts your folder that has the website into the root directory of IIS inside the container. So whenever you make changes to your web pages, because it's a mounted volume, those changes appears inside the container IIS root folder. You can of course run your remote debugging process inside the container and then attach into that. So this is how you get the seamless debugging experience, similar to the debugging experience that you would get in building ASP.NET application or EXE application. We now know how easy it is to containerize an EXE application using Visual Studio. But there may be some times where you need to containerize an EXE application manually. So what I'm going to do now is to containerize the same EXE application I just built, but I'm going to do it manually. The reason why we need to understand is that at some point in creating your CI/CD pipeline, you may decide, hey, I'm not going to use Visual Studio to containerize it, but I'm going to script the build process in a way that I just get an EXE application or an MSI package, install it in the container, and then create an image out of it. So let's see how we can manually containerize an EXE application. I have a sample EXE application that I want to containerize. It's called my batch app. So let's run it and then see how it works. So all what it does is spin up multiple threads and then print some random numbers. If you go to the CPU utilization, you can find that it pretty much uses all the CPU available of the machine. A classic bad behaving application. So let's see how we can containerize this application. So I started PowerShell as an administrator. And I'm going to download an image from Microsoft. To do that, I'm going to call Docker pull, and I'm going to give you the name of the image, Microsoft Windows Server Core. This will go to Docker Hub and download the latest version of Windows Server Core image. So it already identified that some layers already exist, so it's not going to download the existing layers. And there's one layer that is missing. Maybe it's a new security patch or an upgrade from Microsoft. So it's downloading that missing layer. So this layer is a compressed version of the image. So the download is fast. So now it's extracting that compressed layer. So we are almost done. So the download is now complete. And if I type Docker images, you can find the latest downloaded images. So let's run a Docker container. In this case, I'm going to run it interactively. And the image that I'm going to use is Microsoft Windows Server Core. And I'm going to run PowerShell inside this container. So when I type enter, it will go inside the container because I'm running it as an interactive mode. To know the container ID, I can type host name. So you get the container ID. So if you look at the directory structure of this container, you can find that it's completely different from the container host and from many other containers running on this machine. So containers have their own file system. So the registry entries or any configuration that you modified in the container is only visible within that container. Same for the task list. If you look at the processors running inside the container, you can find that they are different from what you find on your container host. Containers start fast because they don't need to start all the processors that you need to start when you run a virtual machine. So let's make a directory inside this container. So I'm going to say mkdir and I'm going to tell it as my app. And I have started another PowerShell window in the container host. So if I type docker ps, I can find the running containers inside this container host. So I have one called 4e69. So what I'm going to do now is to copy my exe application inside my, which is inside my container host under C install my batch into the container. So I give the container ID, in this case 4e69. You can only give part of the ID as long as it distinguished from the rest of the running containers. And inside my container, I have a folder called my app, and I'm going to copy it to that my app folder. So if you look at my app folder, you can find that exe application has been copied. So my exe is now inside the container. I can exit from the container like this because I have copied the file, or I can simply say docker stop and give the container ID from my container host. So I'm going to stop the container that I just modified. So it has the exe that I copied. The next thing I'm going to do is to call docker commit that will save these changes as an image. So the container that I want to save is 4e69. That's the container ID. You can give only part of the container ID if you like. And then I give a name for my image. So in this case, I'm going to call it my app. So from the time I do that, it will save the changes that I have made. So if I type docker images, you can find my newly created image called my app. So I can now run this container image that I just created, but instead of giving all the CPU available, I'm going to give only 20% of the CPU. So image I'm going to run is called my app. Inside that image, I have an application called my batch app. So from the time that I type enter, application will start as normal like before. But if you look at the CPU utilization, you can see that I have sliced and diced my CPU and give only fraction of it. So it's now no longer using the 100% of my CPU. The first thing you need to understand is running a simple container is very easy. You can do it manually, but the challenges comes when you try to run multiple containers. You need to think about how you are going to schedule these containers, because some containers you want to run for a few hours, maybe for a few minutes, and then you need to terminate them. You need to think about allocating available hardware resources for your containers, because you may have a HR application that you want to allocate a small number of memory and CPU, whereas you may have a very compute intensive application where you need to allocate more memory and CPU. So you need to find places where you have leftover hardware resources and then schedule your containers accordingly. And that's why sometimes these bookkeeping tasks, like where you have spare resources, can take a lot of time. So to make your life easy when you run hundreds or even thousands of containers, we have invented these services called Amazon ECS or Elastic Container Service and Amazon ECR, Elastic Container Registry. Amazon ECR is something similar to Docker Hub, where you can keep your Docker images. The only difference is it's tightly integrated with AWS identity and access management systems, so that you can define, for example, hey, these are my production images and they are available only for the servers running or the clusters running in my production environment, and these are my development services, and the developers or your build systems have access to the given repositories. You can easily define the identities for ECR. Elastic Container Service is the container orchestration engine. So ECS knows how to place your containers in available hardware resources and orchestrate your containers based on different parameters. So underneath, ECS is based out of a concept called cluster. A cluster abstract EC2 instances. So some of these EC2 instances, you may already have some running software like SQL Server, or there may be some new EC2 instance that you added to the cluster. The cluster can scale out or scale in depending on different parameters. For example, if the cluster CPU utilization goes above 85%, you can specify to add more EC2 instance. Or if the cluster utilization goes below, let's say 20% of the CPU, you can remove certain EC2 instances. So there are a lot of capabilities to scale out and scale in. When you find that you don't have enough resources to run your containers, the cluster can automatically scale out and scale in. So once you create the cluster, you create something called a task. A task is nothing more than a construct that you use to define the set of containers that you want to run. You can say, hey, ECS, I want to run SQL Server and a website, and these are the containers that contains that application. You also can specify things like constraints. You can specify things like, hey, this is a human resource application, and I don't want to run it in the same EC2 machine where my finance application is running due to compliance reasons. You can also define things like what EC2 instance that these containers should run. And also you can define tags to EC2 instance and then place containers on certain instance but not the others. Also, you can specify the resource demands. For example, if you have a memory intensive application, you can allocate more memory. And also you can define how much CPU that you wanted to have. So once you create a task, you have defined what containers you want to run, its resource demands and the constraints. Then what you do is you create something called a service. A task you can start manually, but it doesn't guarantee that the task will run always. A service is something that you can use to maintain some desired state. You can say, for example, how many tasks that you want to run. What's the deployment strategy? How the auto scaling should work. For example, you can say, hey, this is a website and I want to run 2 containers to absorb the load. So in that case, the service will maintain that 2 containers or the 2 tasks always running. If for some reason one container fails due to, let's say, an EC2 instance failure or to a virus or a patch-in upgrade or you manually deleted it, the service will make sure that it will start a container in another available hardware resource. ECS has some built-in intelligence. For example, it can define how you are going to place your containers when you deploy them. For example, if you use a bin packing strategy, it will first fill one EC2 instance with available containers, and then it will go into the next EC2 instance. You can also define things like balance spread. So in that case, it will place your containers evenly across the available EC2 instance in your cluster. You can also define your custom algorithms if you want, but it's beyond the scope of this presentation. So once you create your services, you place them on the cluster and then run them. So for example, you can run your human resource application along with your finance application and your marketing application. The cluster can scale in and out independently. For example, you may have 1,000 containers that runs on this cluster, but you may only have 4 EC2 instances back in this. You are being charged only for the EC2 instance that back this cluster, but you are not being charged for how many containers that you run. So for example, if you are running 4 M4 large instances, you are only being charged for 4 M4 large instances, regardless of how many containers that you run in the cluster. So behind the scene, how it works is you have these container hosts, which are pretty much EC2 instance that can be in any availability zones. So for example, here I have 2 EC2 instances, a container host in availability zone 1, and there's another container host in availability zone 2. And the ECS can place your containers across availability zones. So for example, if you have 2 EC2 instances in 2 availability zones, you can define some balance spread deployment and then specify some constraints so that your containers will be placed on 2 different availability zones for high availability and disaster recovery purposes, right? Behind the scene, there's an ECS agent which communicates with ECS. So all what ECS does is communicate with this ECS agent to send some Docker commands to invoke and start containers inside your container host. So we will go into much detail later and then showcase you how this works. You now know different ways to create Docker images and then package your .NET application into them. So you can do it with Visual Studio, you can do it manually. So regardless of how you build that application, at the end of the day, what you're going to get is a Docker image. So in the subsequent demo, what I'm going to showcase you is how you can run this image or the application that is inside the image using Amazon ECS or Elastic Container Service. I'm in my AWS console. So go to Elastic Container Service. So here you can find that I already have 2 clusters already created, my Fabricam cluster and my Contoso cluster. My Contoso cluster already has 2 EC2 instances running, and it has 1 service and 12 tasks running. So you can find that it's backed by 2 EC2 instances. So let's go into the repository. So this is where you find Amazon ECR. It's something similar to Docker Hub, but tightly integrated with AWS Identity and Access Management. So you can find that there are 2 repositories already existing. So what I'm going to do now is to create a new repository to keep my image. So click Create New Repository and give the repository a name. In this case, I'm going to call it Hello World. Click Next. So once you create the repository, it gives you some command that you can use to push the image that you created into ECR. So these are all standard Docker command, except only the login one. So you click Done, and then you have your repository created. So if you want to view the command, again, you can view the push commands using that button, and it will give you the standard Docker commands that you need to execute. So I started PowerShell in the machine that I have built this image. So if I type Docker images, you can find that my app is there. So this is the image that I need to publish into ECR. The first thing is to call Docker tag. So I'm going to tag my app latest with the full URL of my ECR repository. So in this case, it's going to be Hello World latest. So when I press enter, it will tag it and it will create an alias for an existing image. So you can find my app already exists and it created a new alias with the full URL of my ECR. The next thing you need to do is, of course, you need to log in into ECR to publish this image. So you invoke expression, AWS ECR get login, and so in this way I can log in. So all these commands are given when you create the repository. So login is successful. The important thing is that the machine has to have right permissions to get the token. And now here I'm showing Docker push and give the full URL. So what I'm going to do now is to go to so the login is successful. What I'm going to do now is to call Docker push and give the full URL of the image. So once I do that, you can find that it's uploading that image. Only the delta changes are uploaded. So it has uploaded the image. So if I go into my ECR and then refresh this, you can find that the image has been uploaded. So it's not everything is uploaded, uploads only the delta changes, and you can find that the size is very small. So once it's upload this image, the next thing is to, of course, create a cluster to run this. So you can run it on existing clusters if you want, but in this case, I'm going to create a new cluster to run it. Right? So select EC2 Windows or networking. You can run Linux clusters, but in this case, I'm running Windows-based images. Give the cluster a name, so call it Hello World. You can run on-demand instances or spot instances. It's up to you to select it. You can select the size of the instance you want to run. So you are built only based on the EC2 instance you are running. You can change them later if you want. So behind the scene, what happens is it's create an auto-scaling group with these instances that you selected. You can select the storage, the security key if you want to remote login into these EC2 instances, what network that you need to drop these EC2 instances. You can create a new VPC or you can use existing one. What security groups, what ports that need to be opened, and what's the role that these EC2s will assume to invoke AWS services. So you can define a one so that it can invoke certain AWS services. So click create. So it spin up some CloudFormation stack and then it create certain resources. So if you go to this CloudFormation stack, you can find that it's creating certain resources like auto-scaling group, subnets, VPCs. So it's basic CloudFormation running behind the scene. So it creates an auto-scaling group. So you remember that we added 4 EC2 instances, and it sets the auto-scaling group to have that 4 EC2 instances. So behind the scene, it uses basic AWS construct to create the cluster. So if I go into my EC2, if you go into auto-scaling groups, you can find that the cluster creation process has created a new auto-scaling group, right, with 4 EC2 instances that needs to be there. So these are typical auto-scaling group. You can change it if you like. So if I go into my task definition now, while the cluster is being created, I'm going to create a task definition to define what container instances that I want to run. So create a new task definition. Here's where I define what is the location of my image, give the name for this task definition. If you want to give special permissions for this, you can assume a role in this task. So what's the network? You need to keep it default because Windows containers only support default networking mode. So here's where I add the container. So you define the container name and then you type the URL. So this can be a Docker Hub URL or this can be ECR URL. So usually if it is a private repository, you provide the Amazon ECR repository URL. So what usually happens is here you can define the latest one if you want. And then of course you can define how much memory is required for this task. So in this case, I'm going to provide something like 128. If you are running a website, you can also define port mappings. So remember, like in this website, this is an EXE application. So there's no any load balancing happening, but I'll showcase you shortly like how to run a website. So I provide the memory that I want. There's nothing port mapping here because it's not an IIS or some other website that is running. So just you can leave it blank. So imagine this is a batch application. So, and there are multiple parameters you can specify here. One of them is the CPU units. So one virtual vCPU equivalent to 1024. So if you want to allocate fraction of your CPU, you define, let's say, 256. So if you want to have half a vCPU, you define 512. So what I'm going to do now is instead of allocating the full vCPU, I'm allocating only 1/4 of it. So 25% of a vCPU is 256, right? Because one vCPU is 1024. So and then I need to specify what's the command that I want to run when this container is running. So remember when we created this image, we put our exe application into a folder called my app and my batch application.exe, right? So this is relative to, so this is, you are referring to exe application inside your container, right? It's not in something inside the container host, but you are referring to an exe application inside the container that you just specified using the ECR URL. So once I specify this exe, what will happen is when ECS starts, it is going to start this application. So by default, you can define for when a container starts to run a default application. But the way I have defined this container is that there's no default application that will start, so I need to specify the command. So you can of course specify things like the DNS servers, how we are going to resolve the host names. You can also specify things like the mount point. So imagine that you have multiple containers that you want to share a data volume. You can also do that, right? So in this simple application, I don't want to share any data or like mount new data volumes. I just leave everything blank and just click add. So once you add this container, so it's now defined. You can add multiple containers. For example, if your application needs to have dependencies, you can add some dependent application. You can define constraints like, hey, this HR application should not run on the same application that human resource application is running. So just click create and you created the task. My cluster, hello world cluster is ready. So let's now run some task on this cluster. So how to do that? Select the cluster, go to your tasks, and then you can schedule a task to run on this cluster. So very easy. Click run task. So here I'm running only one time task. If you want to schedule them, there's a scheduler that you can set it up. Select which version of the task. So every time when you create a new task with the same name, it creates a new version. I have only one version. I want to run 6 of this task in balance spread manner. So if it is, because let's say it will absorb the load. So click run task. When you click run task, what will happen is it will start like 4 running tasks. Behind the scene, it's actually running 6 containers. So 6 tasks running, 6 containers are running on my cluster. As of now, they are in pending state. After a while, they will automatically start. Note that it takes some time if you don't have that image to download it. So you can find that some of the tasks or the containers have already started. 3 out of 6 has started. So let's go into this task and then see where they get scheduled. So if I go into this task, I can find which EC2 instance that they are running. So behind the scene, it's actually running EC2 instances. So you can have 1,000 tasks running on one EC2 instance, right, depending on how you have defined your cluster. So normally in production environment, you cannot remote login into this. But remember, when I created the cluster, I define a secret key. So which means that I can now remote login if I want. So imagine this is a test environment. So what I'm going to do now is to remote login into this EC2 instance where the containers get scheduled. Remember, production environment, we don't do that, but this is just to showcase you, if you want, if you define a key, you can still log in into that and they are just yet another Windows machines. So I enable the RDP access. I connect into that. I browse my, I have the access key for that. So I can now log in into this. So I just type the password, remote desktop into that. And once I remote desktop into that, I'm going to open PowerShell. So I open the PowerShell. So I type hostname. You can find that EC2 instance name, Docker PS. This is the container that ECS has scheduled on this EC2 instance. So I can do some more detail into that. Type Docker inspect, type the container name, 5ADE. You can specify some short number as long as it distinguishes the running containers. So you can find it's running my app, my batch app exe. You can find information like to which cluster that it belongs to, some metadata about it. Of course, if you want to check some more detail, you can also attach into this running container. So you can say Docker attach and then type the container ID to attach into this container. So I'm attaching into the container. And like before, you can find that numbers appearing that showcase you that my application is running. So this is a task. If you want to maintain some desired state, you create a service. So that's also easy. You go to the service tab and then create a service. So service is something that you can maintain some desired number of containers always running, right? To do that, click create under service tab. So which task that I want to run it as a service. So I'm going to select the same task that I created a moment ago. Give the service a name. and how many tasks that I want to run. So this is what in this case I'm going to run 4 tasks. You can specify whether you want to have load balancing. This is a EXE application. I don't want to do load balancing using application load balancer. If you want to auto scale, you can do that. For example, based on CPU utilization or memory utilization, you can auto scale. But this is a simple configuration, so I'm not going to define. I'm just going to keep everything by default. Do not auto scale. Click next. So here I'm going to maintain 4 running containers. Create the task. So if I go into my service, you can find the desired count is 4, running count is 0. So it's deviated from the current states. Now it started 2 containers. Desired count is 4, pending count is 2. So 2 containers are pending starting. Still not a healthy state. So if you keep refreshing, now you can find that it's a healthy state. I want to have 4 desired running containers, and I have running count is equal to 4. So it's in a healthy state now. To stimulate a failure, let's say EC2 instance crash, or you restart these machines due to maintenance, some lightning strike in the data center, I'm going to stop these containers. So you can, for example, stop the EC2 instance that is running these containers. So I'm going to stop 2 containers running. So I'm just manually doing that in this case. So once I do that, what will happen is now the desired count is 4, running count is 2. If I refresh it, you can find that only running count is 2. ECS will understand that there's a deviation from desired state, and it will automatically schedule some other containers to make it 4. So it automatically started the 2 more containers, and they are in pending. Keep refreshing, and you will find that now it's in the healthy state. Desired count equal to the running count. Let's now create a CI/CD pipeline to deliver your software as containers, so that every time a developer commits some changes, the build system will build that software and then publish into Amazon Elastic Container Service. So imagine you have a web application that is behind a load balancer, and this load balancer balance load between 2 containers. So you have the container with the application version 1 running, and this application is backed by 2 running containers. So whenever a request comes, the load balancer directs this traffic to the version 1 of these containers. So inevitably, of course, you get a new feature request, and imagine that there's a developer who builds this new feature. So he's going to use Visual Studio, going to create some changes, and once he make that changes, depending on what kind of source control system that they are using, the developer is going to commit that changes into the source control system. So it could be something like Bitbucket, or it could be something like Microsoft TFS or VSTS. So once the developer commits these changes into, let's say, Microsoft Team Foundation Server or Visual Studio Team Services, what will happen is they're going to be a continuous integration system that will build this software. So in the case of Microsoft Team Foundation Server, it has its own continuous integration system. In the case of, let's say, if you are using another build system like Jenkins or TeamCity, you can still use that. So what will happen is your changes will be picked up by your continuous integration system, and it will start building that. To build that, it's going to spin up a build agent. So this build agent can be an EC2 instance. So if you are using TeamCity, you can add an EC2 instance with the proper tools installed as a build agent. If you are using Microsoft Team Foundation Server or VSTS, it comes with a build agent that you need to install in an EC2 instance. If you are running the cloud version of TFS, which is Visual Studio Team Services, to grant authorization, you can create something called PAT or Personal Access Token, and then authenticate this build agent into your Team Foundation Server or Visual Studio Team Services. So once this build agent has access into your team services or Microsoft Team Foundation Server, So whenever the new change comes, the build agent will build this software. Of course, the build agent has to have certain application installed. The obvious one is Docker. You need to have, if you are going to build Microsoft Visual Studio based solution, you need to have MS Build kind of tools installed. And also, if you are going to invoke AWS services, you need to have AWS PowerShell toolkit and AWS command line toolkits installed in this build agent to invoke certain AWS commands. Once the build agent builds the image, the next thing it's going to do is to using Docker commands, publish that image into Amazon Elastic Container Registry. So you can publish it into your own private repository or something like Docker Hub. It's up to you. And once it publishes that image into Amazon ECR, it's going to invoke the orchestration engine. In our case, it's going to be Amazon ECS or Elastic Container Service to render this image into its cluster. All our APIs are exposed in PowerShell. So in this case, I'm going to showcase you how to use PowerShell to tell ECS, hey ECS, I have a new image with the new application version. Go there and then render this new image in your cluster. We don't limit you from using Amazon ECS. Like for example, for Amazon ECR, you can, instead of using Amazon ECR, you can use Docker Hub. In the case of Amazon ECS, if you say you are going to render this image in your own orchestration engine, like Kubernetes cluster or any other technology that you use, you can still do that. You can also render this image in another cloud service provider if you want, because at the end of the day, what you have is a Docker image which can run on any cluster. There's no any dependency around the technology you are using, because it's just another Docker image. So once the ECS, once you invoke the ECS to render this image, what will happen is that ECS is going to pick this image from ECR and then render it as the version 2 of your application in its cluster. So it can take this image from Docker Hub if you want, but in this case we are using Amazon ECR. So once it renders the version 2 of your application, it has to go, the 2 containers that I have here has to go through some health checks. And once those health check passes, the load balancer is going to direct traffic, user traffic into version 2, and it's going to slowly decommission the version 1 of your containers. So those containers will be stopped and your new traffic will be directed into the version 2 of your containers. So finally, your users will have the new feature in their website. So let's see how I have created this CI/CD pipeline, and then explore how I have built this pipeline using Microsoft TFS or Team Foundation service. So I'm in my TFS server, which I have set up to build a website. So the name of the website is called LulaPets. So let's go into this build definition. So if I go into build and releases, where I have defined the build steps, you can find that I have created a new build definition called LulaPets ASP.NET with Container CI. So let's go into that. Here you can find that I have already created a few builds. So let's edit this to see how I have defined the different build steps. So of course, the first thing I do is I get the source control from here. And then I get the NuGet packages and then build the solution. So these are like normal build steps that you can add. So, and then I'm building the MS build solution. I pass some parameters, build the solution. And this is where I called publish to Elastic Container Registry. So I invoke a command to publish this image into ECR. So it's a PowerShell command that I added here. So in any system, you can add like different build commands if you like. So you have like pre-built actions like AWS S3 upload, you can archive them. So this is a PowerShell task that I've added. So here I'm doing like, first I log in into ECR. This you can log in because the build agent running this script has ECR login permissions. So once it login completes, of course, it logs in behind the scene, and then I'm calling docker tag. These are the commands that you find in your ECR that I'm invoking in this step to tag this newly built image with the full URL of ECR. So this is how it end up. This is the normal image that it builds, lula.latest, and then I tag it with the ECR full URL to publish it. Then of course I call docker push with the full URL of the ECR. So once it published that image, so once this build step is completed, it goes to the next step. So in this case, I'm invoking a command line interface just to showcase you that all our APIs are exposed in command line as well. So I'm going to say ECS, go and update the service. In this case, the name of the cluster called Win3. Name of the service that I have created is called Lula website. So this is the creation of this service is similar to the way that you create a service that I have showcased before. I'm going to do a forced deployment, and the region, of course, it's going to be in Australia. Health check grace period is about 80 seconds, and desired count is going to be 2. So once I run this, what will happen is the ECS is configured to take the latest version from the ECR. So once I do the update service and then set this one up, what will happen is the image is already uploaded. What it will do is it will do a refresh, and when it does the refresh, it will take the latest version that I publish. So you can find the latest version. So this is how I have this is the image that I'm using in my ECS. So if I update the latest version to latest build one and I refresh the ECS, it's going to take this version, the latest version. So what will happen is it will then render the new containers in the cluster. So let's go and then make a build and then see how these build steps are working. Here you can find out how I have configured my build agent. My build agent is an EC2 instance. So I have a build agent called sridutfs build machine for container, because I have multiple build agents configured. In the security groups, I have enabled, if I go into security groups here, build servers, you can find that I have enabled traffic. Now, of course, you should not enable it for internet. You should set it up in a way that it allows you to take the base image either from your private repository or from a public repository like Docker Hub, but you need to go through some kind of a NAT gateway. In this case, I'm opening this all traffic from the internet as an inbound traffic so that I can download the base images when this build agent start building the image. So if you want to have some security control, make sure that you enable traffic so that it can access the public repository or your private repository, right? That's number one. Number two is IAM role. So I have defined one called LF build server. Because this build machine I use for multiple deployment, I have enabled certain different access. But what you really need to do is to give right access to Amazon ECR. So either if you can, so in this case, I have defined Amazon EC2 container registry power user, which allows us to do multiple actions, because it's not only that I publish an image into ECR, I tell ECS to refresh the container with the new image that I publish. So you need to give enough permissions for it to do it. In this case, I'm giving more than the access that I want to give it. And also I use this build agent to do elastic beanstalk deployment, code deployment, S3 deployment. So I'm S3 based deployment. So I have given multiple access. But in your case, make sure that you give just enough permissions for that this build agent has permissions to A, write into ECR to write the new image, B, to refresh the ECS so that it can you can tell, hey ECS, go and then refresh the image with the latest image. So that's the build agent configuration. What I have done was registered the build agent that I created with my build system. So you can find I have different queues, one for containers, one for other builds. So under the container builds, I have a machine called build machine 4, which I have registered with TFS. The way I did it, you can search it on MSDN. I created something called a PAT token or personal access token. To do that, you go into your profile. You should have, of course, TFS administrative access. Go under security. And if you go under security, you can create a PAT token. So I already have created a PAT token here, TFS built agent for container. So this is the token that is being used in my EC2 instance. So imagine that this is, instead of using TFS, you are using VSTS or Visual Studio Team Services, which is the hosted version or the managed version of Team Foundation Server. And you want to register one of AWS built machine against that registered version. What you need to do is to go to your VSTS, or in this case it's TFS, click add, define the expiration date, maybe 128 days, my new container built machine, and you give this one, and then you create a token. So it creates this token. So of course I'm going to delete this, but you can use this token now to register your built agent. And once you register your built agent, your built agents will appear under your agent pools. So in this case, I have already registered this built agent as my EC2 instance as BM4. The best place to look how to configure the TFS or VSTS agent is, of course, Microsoft Documents. If you go into this URL, you can find how to configure the agent for different operating system. It talks about the permissions, how you are going to download, things around which URL you should use to connect depending on which version of TFS you are using, how to download and configure the agent. So you execute certain commands depending on whether you want to run your agent as a Windows service or as like a batch file. So all this information is given on Microsoft documentation. Also, how to create a personal access token or PAT token is also very well described in Microsoft documentation. So depending on your platform, if you use Jenkins or TeamCity, they will have different configurations to configure the built agent. But you need to refer to your continuous integration system documentation, how to generate an authentication token or some other password authentication technique to integrate with your agent that will build your software. So I have this sample web application called LulaPets. So it keeps track of the owner, the name of the pet, and how many steps that each pet ran, right? So these are lazy pets, like my cat in the flat. They are not walking that much, right? So if I go into info, it shows you the container instance back in this. So you can find that there are two container instances behind the load balancer. Every time when I refresh, you can find that the container ID changes because there are two containers back in this. So the application version is still version number 1. If you look at this, so these are the two containers that back in this EC2 instance. So they are running under two different ports, right? Both are healthy. And so this is my cluster. So if I go into my cluster, you can find that there's two clusters, Windows and Windows 3. I have a service called LulaPets. So this is a service that I published before, right? And so now running count equal decide count. The website is in good conditions. If I go into the deployments, right, you can see the deployments that I have done, right? So as of now, there's a primary. So there's no any deployment happening at the moment. So they are in good condition. So application version is version number 1, right? So let's try to make some changes into this application and do a continuous delivery. So I'm on my Visual Studio. So this is the application, right? So this is already integrated with TFS. It could be VSTS, it could be your Bitbucket with TeamCity, or it could be Jenkins, so we don't care, right? So as of now, it's integrated. So I'm going to change something, right? So I'm going to say application version 2, added new features. So this is sampling, develop, adding some new features. So in this case, I'm changing an HTML page. So I can commit this. So behind the scene, of course, I use Git. So I make these changes. So what I'm going to do is to commit this, right? So my build system is configured to take any changes that get committed recently, and it will build the software, right? So let's commit this. So I'm going to say something like version 2, I added new features. So maybe that this needs to go into a testing environment to do load testing, right? So I click commit and push. So that will push these changes into TFS, right? So it could be Bitbucket, it could be GitHub, we don't know. So behind the scene, the build system has started a new build. It's running the build now. So this is TFS. You can see the commands it's executing. So the PowerShell commands. So it's building that image, getting NuGet packages, building the image. So it has container support, the build agent. So it's going to create the image, then publish this image into the container repository. It's publishing only the layers it wants. Because it's doing delta loads, it will publish. The image publication is super fast. So now image is in the container registry. You can find that it started a new deployment into ECS, right? So primary is still serving the request and the secondary started deploying, right? So if it is a live environment, the live users will not see any difference because the load is still supported by the old version, right? So what will happen, so you can find if you refresh the website, still the load balancer is directing the traffic to the old containers. So after a while, what will happen is that these new containers will come alive. So running count of new containers equal to desired count. So then it needs to pass through some health checks. So that's why the load balancer still haven't directed traffic to the new containers, still version 1. So if you go on to the load balancer, what will happen is the new containers will become healthy at some point in time, right? So they're still in initial state. So all containers are, one container is dying, so it's draining, one is healthy. So new containers are still in initial stage, so they need to pass through health checks. So once the health checks passes, you can find that I guess one thing is already passed the health check. So if I go into my the URL and then refresh it, of course now it will direct into the new version. You will feel a slight delay because still it needs to get the IIS up and running. And after a while, what will happen is you will see the application version or whatever the changes that I made appears here, right? So just refresh it. They're healthy. So let me see. Still loading. So IIS loading all the DLS. So yeah, here you have application version 2 with the new feature. So that's how you can easily integrate your continuous build systems with AWS. Hope you enjoyed the session. Thank you.